In the future, there's only one name in phone repair: Repair Room USA.
All right, welcome everyone. This is Richard, Repair Room USA. Today we are going over the equivalent of micro soldering clip notes. If you want, I paid over $3 to get this book. If you want to learn and have a handy little cheat sheet for mobile repair, this is where to get it. I'm going to go over it and I hope you guys enjoy it, and let's get to the video.
What are you doing? Go watch Repair Room USA. And now.
All right, welcome back. This is Richard, Repair Room USA, and today I am going over this book. I'm not going to go over the whole thing because it's really long, but I'm going to try to cover it the best I can. And this is in conjunction with a practical board repair school that I took, and I hope you guys find this an enjoyable read. Now, I think if you've seen some of my videos, you will recognize this sheet. This is basically how most Apple iPhones work. And this is basically they're getting power from a charge port or a battery, going through a charger IC chip, and then that's making the main power rails with the PMU, power management unit, and then those are going out and making the different voltages that are needed for different circuitry. I have gone over this in a different video, so if you want to learn more about that, everything I do in this class, in this video series, I do is basically coming from this gospel right here. So, Practical Board Repair School Master Notes Day 1 Lecture Group. Voltages, currents, resistance, powers versus data, big diagram, RF, red, main board, power diagram, black. This is basically just giving you an idea of what we're doing day 1 in Practical Board Repair School. Next we get to how to guess what chip does. Input. Everything goes from top to bottom or left to right. Output is usually on the right side. So if you're looking basically at a chip, say this is a chip, most of the output lines would be on the right or the bottom, and the input lines would mostly be on the left. So it's going left to right, kind of like how you read a book, or top to bottom. How the iPhone works, big diagram, power systems, delivery, battery voltage to chips and connectors. Amplify battery voltage to create high voltage rails via boost chips and coils. Reduce battery voltage to create low voltage rails via standalone LDO chips or standalone buck converter chips and coils, or MPU chip, LDO, or the buck systems inside the power management unit. So it goes from power, VMAT, to a MOSFET, to VCC main, to the PMU, and then it creates the baby voltages. Battery. Some chips are powered by batteries. VDD, which will be the same as VCC, main. Okay, some chips are powered directly from main. Main powers some boost chips, take main and increase voltage, backlight driver. You got the chestnut, Mesa. Some chips reduce the main voltages, which buck conversions with the PMIC, power management chips, LDO conversion within the PMIC, standalone LDO, the camera, USB accessory, the fingerprint sensor, the MESA sensor, which would be tied to the 1.8 rail, which is the power button. Ultimately, main is delivered by the power management unit, PMU. PMU produces other baby voltages to other systems. PMU is at rest until prompt to boot. Power management always produces one voltage rail at least, and that is the one to the power button, which will be 1.8 volts. Always goes to the power button. So it's always ready and willing to activate. Data, AP EEPROM, baseband EEPROM, the clock crystal, and the CPU, which is equal to AP. Symptoms of these problems: not booting, appears brain dead. And we're going to go over, this book will go over some of these troubleshooting steps on what to look out for and how to test different phones problems that you may get and how to diagnose it. Okay, no boot, appears brain dead, can't pass restore, boot loop, the Apple logo, then dark, auto boot to DFU, backlight only, no image. Check DFU, rule out software with an update, preserve data, or restore, erases data. So if you do a software update, you can either update it or you can restore, but that erases everything. Look for hardware problems that damage data lines. I2C, I've gone over this in other videos, but I2C is very important. SPI, JTAG, or UART, and so on. Okay, so look for problems that may damage the data lines. Check crystal and EEPROM voltages. Rule out NAND. Replace the NAND, remove read NAND serial, write to new, reball, replace, restore. If not solved, reball the CPU, bottom swap, the CPU, SDRAM, NAND, EEPROM, or BB, which is the baseband CPU. Software programming. We have no way to interact with encrypted data if the phone will not boot into iOS firmware. LLB, iBoot, ISO, iTunes Restore. Special topic, missing censored data, 3-minute boot loop. See censored data blog post at www.ipadrehab.com. Signs for a 3-minute boot loop. Phone boots and stays on for approximately 3 minutes, then crashes and reboots again. Problem. Any missing thermosensor data. Different phone, different ISO required, different sensor input. Examples. Thermosensors can be found within the battery. A lot of phones, they won't boot up unless there is a battery connected to it. It's got a sensor in it that needs it. That's part of I2C. Charger port. Power button. iPhone 11. On the board itself. Example, iPhone 12 Pro Max layer damage. Okay, 3-minute boot loop. Practical technical proficiency. Working on an iPhone logic boards. Learn to read the pins, pads, vias, traces, and grounds. Learn to read the board. Learn to look at it, diagnose it. Soldering skills. Recognize and prevent oxidation. Oxidation is nearly invisible chemical layer that prevents formation of solder and chemical bonds. It happens whenever heat and oxygen and metal are together. Use lots of flux. Flux is super important. If you're not using flux, it will not flow, it will not stick. I've done plenty of examples in it. I did an example yesterday on if you don't have enough flux, your solder is not going to flow or melt. Look for dull gray elephant ear pads. Must make shiny puffy pillows. I've gone over this too in some of my previous videos. Soldering skills. Learn heat balance. It's very important that you learn your machine. Just because my machine, I tell you that it's at 360, airspeed 60, that's the normal temperature of it, doesn't mean yours is going to be there, but it'll probably be somewhere around that area. The 3 different types of solder, I've gone over this. 217 Celsius, that's the factory lead-free solder that comes in every single new electronic device nowadays. The 183 Celsius, that is the stuff that we use all the time to solder, normal everyday solder. It's leaded. It's a combination of 63 and 34 tin. It's the good stuff. It's the military grade electronics. And then we have the 138 or the 148, there's different ones, near low melt lead-free maybe not strong enough, but we don't know yet. We do know it's brittle. So that is only used in certain situations, especially when you're doing layer boards. And on that, I've gone over in this channel. And if you watch it, you would know. Raising temperature just to the melting point. That's your goal. But remember, this solder, just because the melting point is 183, it doesn't mean that you can set my iron at 183 and it's going to melt, because it's sitting on a heat spreader. It's sitting on some kind of thing that's going to spread the heat out, so it's going to suck all the heat from my iron. That's why it's really important to have good equipment that will stay hot. Heat goals. Raise the temperature just to the melting point. Heat just the compound you're working on. Understand the effects of heating underfill, bridging from solder pressure, and loss of contact to the board. Heat from your tools is absorbed by the board. Heat balance. Heat balance is affected by almighty ground. The heat sink of the phone is the logic board. Metal board holder, tweezers, the shield, the thickness of the board, airflow, tape affects it too. Heat balance and strategies of the toolbox. Change alloy. Convert the standard lead-free solder, the 217C, to 183 leaded solder, 138. That's the lead-free bismuth solder. Okay, low mechanical strain. Avoid soldering with factory 217. Very hard to work with. You don't want to do it. Use a bigger tip to deliver more heat. Add some top air or a bottom preheater. That helps. Increase thermal linkage. Use soldering on the tip to make the tip fit into the joint better. Increase thermal linkage. Use solder on the tip to make the tip fit in the joint better. Adjust how the board sits in the metal holder to either protect or expose area to heat. Hot air. Match nozzle size to the chip. Smaller nozzles, less airflow. Larger nozzles, higher airflow to get the same effect. So if you got a bigger nozzle, you got to use more air to get the same effect of a little nozzle because it's going to go, the air is going to be blowing through there faster. You can kind of hear it though. You want to get an ear for it. That's why a lot of the videos I do, I try to not use any cuts or speed ups because I want people to hear and know how long it actually takes. Learn to analyze the balls under the chips. If you get flat tops when you take the chips off, you have used the ideal temperature to take it. So if you're getting flat tops on the chips when you're removing it, that's perfect, that you're doing good. Learn to indirectly heat the area to minimize heat at the underfilled chips. For underfilled chips, use the blast off method. So you have chips, we're going to be doing that here soon, that have underfill. I'm going to show you the way that I learned how to cut around it, because if you don't do it right, you're going to mess the board up, you're going to knock components off, and it's just going to make your life crazy. Clear underfill border with a thin tool at 200 hair dryer heat. Raise the temperature very high to 220 Celsius and approach the chip directly with a small nozzle when prying up. Chip will fly off in 5 to 10 seconds. So that chip at 420 Celsius, that chip should be flying off of there really quick. And if it's not, it's probably because you're doing something wrong. Safely removal of the chip. If no underfill, use custom hook tweezers. I have showed that on this channel, how to make those. And those is, you get these titanium blue tweezers that you can find anywhere, and all you have to do is just bend the little tips of them on the inside a little bit so they're hugging, so when they grab the chip you can actually lift up the whole board with the little bends on it, like that. Day 1, safe removal of a chip. If no underfill, use custom. Okay, I did that. Grip it like a piece of paper. Do not allow tweezer tips to flex inward at all. Add flux. Heat chips with hot air. See chart for temperature guidance. For the typical mobile phone board, begin around 360-60. That is normal air temperature for most things. Use a donor board to add or subtract 10 degrees from the base on this time. That's how you figure out if your machine is decent or not. You have to use, that's how you find out if your machine's airflow is correct. You have to practice on donor boards first and know what the normal temperature of your soldering iron should be at. Is mine 360 or is mine normal 350 or 370? Or 380, is that my normal for my machine? Safe removal of chips. Watch your angle. Raise shoulders to help point air straight down on the chip. You want to have your hand tucked in, and you want this still, and always use the same technique. You want your shoulder in and have the hot air well gripped, the button where you want it, and that way you can do things while you're holding the hot air steadily. It's something that you have to practice. Learn to reball a chip. Make dry paste. When you're doing reballing and you're using 148 or you're using 183, you want to make sure this stuff is dry. You want to pat it down with a paper towel or let it sit out overnight and make sure it's dry. The drier the better almost. Make dry paste. Add lots of flux to remove old balls with an iron. Clean the chip with alcohol and dry. Inspect. Fit into the stencil and check for dirt. Balance, want it flush. You want the stencil and the chip to sit flush with the stencil. Tape the chip to the bottom of the stencil with Kapton tape. You can do that. I've showed how to do this in other videos. That is a way to do it. Apply dry paste with square blade. Make even. Clean excess paste. Heat slow airspeed at low temp. Example, 330 Celsius at 30% airflow. Start up high. Sneak up and control the airflow to make the balls. When you're doing the reball, that's the temperature you want to use for your machine. Inspect, address any high or low balls, add flux and refill if necessary. Shave the balls and add paste for example. That is something that I've gone over in other videos on this channel. Clean the stencil with alcohol, or if you have a ultrasonic machine, use that. It works really good. Gently release chips, add flux, tighten up your balls, reflow. Clean, inspect on an angle. Inspect top of the chip for dings. You don't want any dings. How to prepare the board for placement of the chip. This is other things that I've gone over on this channel. Use the largest iron that can fit to maximize heat transfer. Add plenty of flux continuously. With a gentle girlfriend touch, float the inner iron over the pads. Don't be afraid of the heat. Avoid touching any area components. Learn to read the board. To recognize signs of abrasion of solder mask to avoid this. Inspect for any problems, bridged or missing components. Only solve problems that are problems. Clean with alcohol and a Q-tip. Inspect again on an angle. Learn to identify bona fide problems. This is how ZXW comes in handy. How to identify pads that are missing, need replaced, or are NC blank pads that you don't have to worry about. How to identify bona fide bridges versus two areas of metal that have lost their paint and appear connected because they are meant to be connected. How to install the chip. Add small amount of flux. You want to spread it out nice and thin with blow dryer heat. You don't want a lot of flux on there because the chip will float away. Place chip with tweezers. You may gently baby gate the chip with tweezers to hold into place, or simply sneak up on it like I've showed you in other videos. You want to sneak up on it and slowly heat it while you bring your temperature in with hot air, and to seat the chip with no tweezers. Never touch the top of the chip while heating. I've seen this in other videos and I don't understand how they are touching the chip, and that is going to cause the chip to smush and cause all kinds of problems. It's the last thing you want to do. Use your favorite hot air flow settings to resolder the chip. Wait for the chip to lock into place. Give about 5 seconds time above liquidus. That's when your flux begins to bubble and the chip begins to jump up and down. Then you count about 5 seconds. I have showed this in other videos on how to do this. Wait for the chip to lock into place. Give about 5 seconds time. Okay, I did that. 5 seconds to move a second time, melting the ground balls. Examine the chip on an angle. Check to see if it is flat and the balls look like a hamburger patties and not beach balls. When you're doing that, if you can see the chip at an angle, you want them to look like hamburger patties, not like beach balls. If they're beach balls, that means they're too spread out and you're going to have to redo that board. All right, day 2, practical board repair. How a circuit can fail. Does it short? Is it open? Is the chip upstairs not doing its job? Okay, a lot of this stuff you can test with a multimeter. Short circuit versus an open circuit. Know how to tell the difference. High current. heat, inappropriate path to ground, hole in the balloon, current leaking, diode mode resistance to ground is low. Example, low equals 0.0. If the line is short somewhere, the line will be short everywhere. If that circuit is short, it will be short everywhere. And how to do that? You use something like this, an iBoot. You hook it up to the motherboard with the connector. You hook it up with one of these, say this one's for the 7. You hook it up to the motherboard and you will read this. And if it's shorted, this book will tell you exactly what to look for to know if things are shorted. Broken open line, aka drawbridge, is blown up. When you have a broken line, when we think of open, we think of a good thing, but really in electronics, open is a bad thing. The open is like an open drawbridge. No electricity, nothing is getting through there. There's nothing getting through there at all. It's not shorted, it's just open. Blown filters, that will cause an open line. Knocked off resistors, bad connector joints, blown diodes, loose coils, etc. Any inline component that is damaged, missing, or lost in the diode mode will give you either a very high value, a crazy ohms value, resistance value, or it'll say OL, depending on your multimeter, how accurate and good it is. All right, board tour worksheet, the components, what do they do and how do they fail? An inductor, which is a filter. Coil, those are all inductors. Okay, you can look in the schematics. It will be these like M&M looking, bump looking things. That's an inductor in the schematics. What does it do? It resists store electricity in the field, changes in current. How does it fail? It's usually open because all it is a wire. If it messes up, it's not going to short because it's not going to ground. So what is it going to do? It's going to open like a drawbridge. Capacitor, that's the symbol for a capacitor. There's also different symbols. What does it do? A capacitor, it basically stabilizes the electricity. It makes it to where the electricity is even. That's why when you look at a lot of these repair guys and they're taking off capacitors and they're not putting another one on, it's because you don't have to have another one on there. It's not going to really do anything. It might not be as even, it might have little hiccups, but it'll still work. How does it fail? Usually when capacitors fail, they short. Resistor. Those, if you knock a resistor off or something happens to a resistor, then that is very important and you do have to replace these. Resistor symbol is like that. What does a resistor do? A resistor is necessary for adjusting current and different values that you want to get on a circuit. It just basically you're manipulating the flow of electrons with resistors, and they are 100% necessary board in any diagnostic. How did they fail? They usually open. Inductor, which is a coil. This is the symbol for a coil. What does it do? It makes the EMF that opposes it, the electrical field that opposes it, when it increases or decreases. How does it fail? Usually open. Diode. This basically is a one-way street for electricity. It makes current flow in one direction. How does it fail? Usually open. A MOSFET. Learn how to identify N-type and P-type. And basically, this is the symbol right here. N-type is going away from the source. There's usually a source, a drain, and a gate. And the gate is basically the switch to telling it to turn on or off, and then it will have a source and a drain. That is something that you can go on Louis Rosman's. He explains it a lot better. The Beginner's Guide to Electricity, Unprofessional Edition. Look it up. It's very easy. It's very good. And just like I told you, it's basically a switch. How do they fail? They usually short. Integrated chip is basically, and all those integrated chip with legs or whatever, it's basically a whole bunch of these other things that I just talked about inside all jumbled into one chip. Two big multimeter tests. Diode mode test, easy and fast. What is it? Why do we use diode mode all the time? Basically, reports an indirect measure of relative resistance of the line to ground. Actually measures the voltage drop of by injecting a small voltage, but who cares about that? It's confusing detail. All you have to know is diode mode will let you know if something is shorted or if something is open, and that's all it basically does. and it's very easy to use, and it's very fast. Instead of having to use ohms or something like that, which you'll see it count up slowly, with diode mode, everybody uses it because it basically lets you know if it's shorted or if it's open. What do the diode mode results in mean? Close to normal, not short or open, compared to known good board or ZXW. That's how you can test. You can either have a good board and test the values on a good board and compare it to the broken board, or you can use a program like ZXW and hope that the values are right. But usually with some of these things, as long as it's 0.3, 0.4, 0.5, it's probably okay. Higher than normal, open line somewhere. If you get a value that's higher than normal, that means there's probably an open line somewhere around that circuit. Or lower than normal, which is a short to ground. Remember, a line with very low resistance to ground is ground. Has a path to ground, is connected to ground, can hold a voltage because it would go straight to ground like a hole in the balloon. Short to ground, all of these mean the same thing. What this is, if you haven't seen one of my first videos, is basically electricity. So pretend that this wire is one wire and I am putting electricity is pressure. So right now there is 0 volts in this wire, but if I put voltage on it, pretend like I'm blowing into a balloon. Now I got 2 volts in here. Now I got 3 volts in here. 4 volts in here. So the voltage will stay in this wire as long as I don't touch the ground. What happens if I touch this wire to ground? You lose all the voltage. It all goes to ground and it goes back to 0. So I blow this back up to 3 volts. What happens if I go and I take a trip and I come back in a couple days? It'd still probably be 3 volts. What happens if I go and take a year trip and come back after a year? It'd probably be a little bit lower. That is how electricity works. It's like pressure. All right, voltage test. Can find problems when there are no short or open on the line. Use to be sure the line has correct voltage after you already know there is no short or open. How to do it. You must have a board under power, battery or DC power supply, and booted, with screen attached and any software app open. Camera app open if you are testing the camera. Set the multimeter in DC voltage mode, that's with the line up top of it, and then put either probe to ground or a second probe on the line, read voltage compared to the schematic or known good board. That is to make sure when you are doing things that you have all the correct voltage values present that you're supposed to have. When that PMU, you want to make sure that all the voltages are there. I found an open line. What now? Well, start at the connector. Move down the line toward the chip doing diode mode test at each component to identify whether it is no longer open. This will show you where the line is broken. Replace the component at the break. Confirm normal resistance is restored at the connector. This you can use either the schematic and the board diagram, and you can go through and you can find out using a multimeter on diode mode where the problem is at. I found a shorted line. Now what? Short detection strategies, a visual exam. Vote. What is the ugliest chip or cap? Okay, vote it off the island. You can do a visual exam and you can usually tell where the problem is at, especially if there's water damage. Heat detection. Inject voltage on a shorted line to find heat. If you know that that rail is shorted, somewhere along that path, you can use a program like ZXW and it will show you what is connected to what, and you can actually inject voltage on that line and then use a thermal camera to see where the shorted component will usually get hot. Remember, what gets hot is the point of high resistance, not necessarily the cause of the short. If current must travel through a high resistance point, like a chip, like a MOSFET or a PMIC, in order to reach the shorted line, the chip will always get hot. Example, Injecting voltage through the battery connector of the VCC main short. The battery main MOSFET will always get hot. So just because it's getting hot does not mean it's, it's shorted always. Example 2. For a short due to a simple bad cap on the PMIC output, the PMIC will often get hot because the current must go through the PMIC to get to the short. Experience. Is there something that tends to go bad for a shorted line in this device? Is that have a history of these components shorting or failing? Or you can brute force it. Say goodbye to every cap and chip on the entire line until you eventually find the one that is shorted. I didn't find any open or shorted line. Now what? Use voltage testing. Find a missing voltage. If none, if you are sure this isn't a parts problem, rule out, before you start diving into the motherboard, rule out that it's not a motherboard problem first, that it's not an accessory and it's not some other part of the phone. And the only way you can rule that out is to have a good working known chassis and completely move the motherboard to a known working phone that is working fine and testing it on the working chassis. That's the only way that you're going to be able to rule out whether it's a parts problem or if it's a board problem. Once you find the missing or low voltage, check again for a short or open. If none, then follow voltage to source. Why is the chip not doing its job? Does the chip have power? Test for voltages. Is the chip told to turn on? It will have an enable. These are data lines. A reset. And AP signals are okay as far as you can tell. No long screw damage or missing resistors on the line. That is something that you can do when you inspect the board. Buddy's okay. Are the chip's accessory components working? Coils and special caps that the chip needs to do its job. Are they okay? Replace the chip. Putting it all together. General troubleshooting when the phone turns on but problems. Example, no image. Phone is on but there's no image. Rule number 1. You don't have a board problem until you prove you don't have a parts problem. Always think, how did it come to be this way? The most important to being a technician is to be able to problem solve. Use all the tools that you have to problem solve. Find out if this is a common problem on this phone. Find out what other people, they're diagnosing. There's a history of these phones. A very, very good recorded history on other people having the same problems. It will probably be somewhere on one of these YouTube videos, the history on this exact same problem that you're having. Always think, how did it come to be this way? Take a history. Crisp visual exam. Is there water damage? Problems? Follow the water. Take note of the damage before cleaning. Do not apply any voltage until clean. Is it been dropped? Checked coil housing. Possible cold BGA joints under the chips. Lifted coils. Bad caps that look good. Bend. Flexion based defects. Is the board been bent? Has it been crushed? Charger damage, possible TriStar, Tigris, MOSFET damage, including brain dead. That's why you have to have a TriStar tester. That's very important. Charger damage, possible, okay, I've done that. Signature problems. Is this a known common problem? If so, execute common solution first. Start with the schematics. Start with the connector. Research the lines that the connector. Make a list. Power for this function. Data for this function. Diode mode the lines. If it open, diode mode if it's high or OL. Find out why. The filters, resistors, diodes, coils, chips, connectors, missing or damaged or loose. That will all give you an OL. Find out if there's a short. Diode mode, if there's either a low diode mode or zero, deploy short detection strategies. A visual exam. Vote the ugliest off the island. The ugliest chip will probably be where the problem is at. Heat. face any freeze spray, or you can use your thermal cam. Experience, is there a cap or a chip that goes bad in this scenario? Brute force it. Find that fucker. Start taking things off that are good until you find the one that is bad. If not, short or open, diode mode is close to normal. Investigate the guy upstairs. Trace the line to source chip. Do a voltage test. If the voltage is normal, this line is fine. If the voltage is low, find out why. We are going to go over this on the next one. I don't want to make these videos too long, but if you want to look, you're going to get all these cool little tricks, how to diagnose bottom boards, how to do the passcode, Face ID, flood projectors, connectors. There's a whole bunch of good stuff on here. If you are interested in learning, that is what my channel is about. I see a lot of YouTube channels that are very good and they know what they're talking about. They usually have all these sped up takes, and you can't get a feel for some of these things, especially when they're getting sped up. So I hope you guys learned anything today. Please subscribe for the second part. Like, and I'll see you guys next video.